Okay, so this is for the formative assessment here, right? Number 5. Remember, what would positive charge do, right? Never forget that, right? So the electric field due to A is toward A, because a positive charge, of course, would be attracted to A. So here's our electric field of A. The electric field of B is away from B, right? So let's see, we're 1, 2, 3 up and 1, 2, 3 over. So sure enough, that's a 45-degree angle. Ooh, that was good. Here's our electric field due to B is that way, right? And this angle here is 45 degrees because B is 1, 2, 3 over and 1, 2, 3 up. It's symmetrical, right? And then this angle right here, that angle is the inverse tangent. So theta A is tan minus 1. What is it? 1 over 3. Right? The opposite side, if we draw a little triangle here, right? The opposite side is 1, the adjacent side is 3. So opposite over adjacent. So second tan of 1 divided by 3. That's our 18.43 degree angle. All right. We got it. We're all set. We're ready to go. So let's figure out what these electric fields are. So EA is, and this formula is not in the data packet. Whoops, KQ turned into a G. KQ over R squared. That's a Q, I promise. So that's going to be 8.99 E9. What's the electric field? A is 1.8 microcoulombs, right? Okay, notice I'm not putting the minus sign in there because I've already taken into account the negativity of A by saying, look, the electric field's toward A. Okay. It'd be weird to put the minus sign here and just mess you up. Okay, so this is, A is 3 to the left, so 3 squared plus 1 squared. I'm doing the distance formula, right? And then, of course, that's squared. I'm going to ignore that in the next one. And, you know, there it is. Okay, so I'm going to do, on my calculator, go alpha F1, enter. Grab that fraction, 8.99 E9 times 1.8 E minus 6. Okay, and then it's over 3 squared plus 1 squared. All right, let's see. Do I have it right? I do. It's so good to check. 1618.2. And that's newtons per coulomb, and then it's A. So A is, it's left and up, and it's at 18.43 degrees with the x-axis, right? All right. I always find it good to write the angle right next to the thing so you don't mix them up. You want this to go with this, right? Okay, so EB, let's see, B. This is the one that's going to be at a 45-degree angle up and to the right. Okay, so the same thing, right? It's going to be KQ over R squared. So K is 8.99 E9. B is 2.6 microcoulombs, so 2.6 E minus 6. And then how far is B? B is 3 to the left, 1, 2, 3, and 1, 2, 3 down. So it's going to be 3 squared. Okay. So I'm going to go, what am I doing here? 2.6. All right. So I've got 8.99 E9 times 2.6 E minus 6 divided by 3. This is the square root of 3 squared plus 3 squared, and then that square root is squared, right? So you don't see it, but it's there really. Okay, so boom, and this is 1298.5 bar. Newtons per coulomb, and this is right and up at 45 degrees. And it don't matter whether that's with the x or the y coefficient. It's like, all right, what do we got? Okay. And now we get to the partitioning of our space. Okay, so let's put EA here. EB. All right. break my screen by going all the way to the edge. Okay, so let's see. This is like one of the best parts of these, is dividing up the space. Actually, the best part of these is just getting them done. Okay, so let's see. All right. I'm really trying to put a positive spin on this. Okay, so this is our x direction. This is going to be our y direction. Okay, so A, here's our A. A is to the left. So our x component is to the left. And then it's up. So our x component will be negative. Our y component will be positive. Because it's to the left is negative x and up is positive y. Okay, so A is 1618.2. And then it's the adjacent side, so it's going to be cos of 18.43. All right, are we ready for this? Let's try it. Boom, cos 18.43. This is 1535.2 roughly. And that's newtons per coulomb and in the x direction. So it's to the left because E electric field is toward A and A is to the left. Okay, I'm getting a little punchy here. 1618.2 sine of 18.43. So the y component's right here, and it's the opposite side of that angle. So we're using sine. SOHCAHTOA is all we're doing here. So let's grab that. Let's change the cos to a sine. And that's 511.7. That's newtons per coulomb, and that's in the y direction. Okay, boy, we're almost there. Okay, so B. B is, let's draw these components. It's to the right, and then it's up. To the right and up. Okay, so our x component will be positive. I'm positive about it. The y component will be positive. Okay, so this is 1298.5 times cos of 45. This will be 1298.5. Technically speaking, sine of 45, right? Okay, so let's find that. Where's 1298? There it is. Boom, cos 45. And it's 918.2. That's newtons per coulomb in the x direction, right? And then, of course, this is the same thing, 918.2 newtons per coulomb in the x direction. I'm sorry, whoa, y direction. Punchy. Okay, so there we go. So let's see. This is, so this is to the right. That's positive. That's good. These are equal. That's up. This is up because the y component's up. And now we're just going to add these guys together. So let's go opposite of this guy, the 1535 guy, plus the 918 guy. This is minus 16.666, minus 616.9. It's been a long night. 4, and that's newtons per coulomb, and that's in the x direction. Okay. And then this guy, if I add these guys up, let's go a little bit of that 511 guy plus the 918 guy. That's 1429.9. And that's positive as well, and that's newtons per coulomb in the y direction. Now let's see if I can draw this. Let's see, it's to the left and up, okay? And it's up more than twice as far as it goes left, right? So let's see if I can draw this. This is like the final test. Here is the, oh, that's so good. I'm getting so good at that. All right, so this angle right there, that angle theta is equal to, so this side is our 29.9. This side is our 616.94. Right, so theta is tan minus 1 of opposite over adjacent. So here's our opposite side, 1429.9 and 616.94. Okay, so inverse tan of that guy divided by this guy. Sorry. Got a lot of sixes here. This is 66.66 degrees. So I think we're going to have to say 66.7. I didn't plan this, by the way. So this is 66.7 degrees, right? And then we can find this magnitude. I'm going to do 616.94 squared plus 1429.9 squared. Square root. Are we ready? Here it comes, man. I'm so ready to be done with this. Okay, so I'm going to go this guy. Oh, I gotta put parentheses around them. Oh, this is such a pain. So I can insert parentheses. Okay. So just be careful with your TI calculators. I've seen kids get these wrong because they leave the minus sign in there, and your TI calculators will square a negative number and get a negative number because they're wrong. All right, and I'm getting 1557.3. So this is this 1560 that you see as the answer. That's rounded. So yeah, there we go. This is newtons per coulomb, and that's our magnitude. There you go, sports fans. So double check all your steps. Double check these angles. Double check that you put this in the calculator correctly. Double check, double check, double check. Because if you mess up one little thing, you mess up everything. And it's a nightmare. But I have a good feeling. I've done 5 in a row without making a mistake. Well, okay, I made one mistake. Good enough anyway. Hope that helps.